I am going to attempt to make this video as short as I can because you have an investigation to do today and you will want to spend some time on that. Before you do the investigation, there is a bit of information here about airbags and how they work. And then once you have finished watching, or once you have finished reading these two paragraphs, it will be helpful if you see this video. I am hoping it allows it to be linked up right here when I post this video so that I can watch it with you. Let's see.
That would restrain occupants in their seats, whether they liked it or not. The race was on to develop the airbag, then considered the ultimate passive restraint.
So a passive restraint means that the government decided to encourage car companies to put something in the cars that would help people not get injured during collisions without people having to take the initiative to put it on. So the government sort of stepped in to take care of people's choosing not to wear seatbelts.
Creating safe airbags was an enormous challenge, and there were no false steps. Engineers had to determine how big the bag should be, materials were best to use, and how to inflate them within 30 milliseconds after impact without blowing them apart. Airbag deployments are violent events. They use explosives to generate the gas needed to fill the bag.
So now we get to the connection with our states of matter. Airbags are able to be packed away flat inside the steering wheel and the console, but explosives fill them with gas. That means a gas must be matter because it takes up space.
When the airbag deploys, some gas does seep out. To be sure it wasn't toxic to humans, Mercedes carried out a series of tests. The first ones involved putting a cage full of canaries in the automobile.
The canary has a wonderful feature. It's capable to trace for very small amounts of toxic gases. And so we used canaries in the interior of the passenger compartment. And they got nervous when they smell or if they feel toxic gases, very small amounts.
The canaries were unharmed by the gas, although they didn't like the noise airbags make when they deploy. This is the airbag module.
So look it, there's no air in it right now, and it's flat.
It's designed with a single canister that holds the gas that fills the bag. On top there are two initiators. In a minor accident, only one initiator fires.
So this also gets into the connection with what you are going to do. You are investigating to compare one initiator and two initiator designs.
The bag inflates smaller and softer.
That was one initiator.
In a high-speed accident, both initiators fire, and the bag fills completely. The third option is no deployment at all. Under the seat is an electronic scale that directs the bag to deploy only if the rider is above a certain weight. At the heart of the system, a computer.
We need to know how severe the crash is, the size of the occupant, whether the occupant is too close to the airbag or all the way back, whether the buckle is engaged or not. Based on that information, we will have a soft airbag, or a very fast hard airbag, or no airbag at all.
Given that information, then, you need to compare one initiator and two initiator designs. You're going to attempt to lift objects, and you get to decide on the objects. I'll check with an adult first. Don't try to lift big, heavy objects like TVs that might fall over on you. Go for things like books and chairs that are suggested here. So do be sure that you have an adult there while you are testing these things, just in case they go in a direction that you can't foresee. You'll need a Ziploc bag and straw, and you'll need someone else to do this with you as well, because when it comes to two initiators, well, you're putting the air in one bag. You can't exactly put the air in two bags. You are going to zip the straw into the bag, leaving one end sticking out so that you can blow into the bag without letting the air escape. So you blow into the straw puts the air into the bag. Consider taping the bag around the straw so that the gas doesn't come out between the Ziploc and the straw. Now you're going to test the strength of the airbag, put it flat underneath different objects, then blow into the bag and see what objects you can lift, and then find an object that you cannot lift. And so here's how you fill out the chart. What is something you lifted easily, that you barely lifted, and that you could not lift with just one initiator, with just you? Now go with your partner. It could very well be that your partner did not try to lift something. So you go ahead and find two things that can't be lifted alone, and then have someone work with you. So you put your airbag underneath, they put their airbag underneath the object, then both of you blow into your airbags and see if both of you can lift the object. Your conclusion then. When I used my airbag, when I just used my airbag, you could say when I used my airbag alone, that almost would sound better, comma, I was able to. Then, when I worked with a partner, both of our airbags were able to. And this should be proving to you that gas does take up space and it does have mass, because by lifting all of these objects, you are only putting gas underneath them. And that gas, that air, is what is lifting them. So have fun exploring the fact that gas takes up space and has mass.